All right, so today we are going to be talking about 7-7, base E, and natural logs. Okay, so yesterday in class we talked about common logs, which are logs that have a base of 10. Base E logs, or natural logs, are very similar, except instead of having a base of 10, they have a base of E. Okay, so anything with a base of E is called a natural log. Okay, so what is E exactly? The value of Euler's number, E, is approximately 2.71828, etc., and it is referred to as the natural base E. An exponential function with base E is called a natural base exponential function. The inverse of a natural base exponential function is called the natural log, okay, which are the two things that we are going to be looking at today: natural base exponential functions and natural logs. So it is just a variable that represents this number 2.71828, etc. All right, now just for reference, we have two graphs here. An exponential growth graph using e to the power of x, so a natural base exponential function, and the inverse ln of x. Okay, so natural logs, instead of writing log base e, we say ln for short, natural log. Okay, now this is just an exponential decay function of the same thing, of your natural base exponential function and natural log. You don't necessarily have to draw both of these graphs in your notebook, but if you would like to for reference, you are free to do so. So the first thing that we are going to talk about is writing equivalent expressions. So going from log to exponential or from exponential to log. Okay, so as I said before in that last slide, ln just represents natural log. Ln is the same as log base e. So if you see something that says ln of 4 equals x, you can rewrite this as log base e of 4 equals x. And once we're in this form right here in the middle, we know how to go to exponential. You take your base of e to the power of x equals 4. E to the power of x is equal to 4. Now in reverse, we can also go from exponential form to log form. So e to the power of x equals 12. Our base is e, so log base e of 12 equals x. Log base e of 12 is equal to x. Okay, now like we said just a second ago, log base e can be shortened to ln. So ln of 12 is equal to x. Okay, so that's how we're going to practice going from log to exponential and from exponential to log. On the next slide, that's exactly what we're going to do. Now, to make this video not an hour long, I've already done some of the problems for us. I've filled them in already and I've left them on the screen. So as we're going through the slides today, just pause on each one that I've already filled in and copy them down into your notes as well. I just didn't want to do 4 examples of each and take up an hour of your time with these notes. Okay, so I'm going to do, I think, 1 example of each type of problem as we go through today. But there are going to be other examples that are already worked out. Just pause the video, copy those examples down as well. Yes, you do need to copy those down. Okay? So first thing we're going to do is go from exponential to log. Okay, so in this first example, we are going to write it as log base, notice base is e, of 8 is equal to x. And as we know, we can rewrite log base e as ln. So this is ln of 8 is equal to x. All right, now if I go in reverse and I have it already in log, I want to go to exponential. Okay, so for this problem, I'm going to start by writing it like we're used to seeing it. ln of 10 means log base e of 10 equals x. Now that I have it in that form, I can write it how we're used to seeing it. Log base e of 10 equals x is the same thing as e to the power of x is equal to 10. And that's it. Now, as I said just a second ago, there are a couple more examples for you to copy down. So go ahead and pause the video now and copy those examples down. And when you're done, go on to the next slide. The next thing that we're going to be doing with these natural logs is simplifying expressions with e in a natural log. Now, when we were dealing with our normal logs, we had different properties of exponents that we could use. We can use those same properties when we are dealing with natural logs. Okay, so for this one, we have 3 ln of 10 minus ln of 8. We know if we have a number out front, we can bring that over here and make it our exponent. So we can rewrite this as ln of 10 to the power of 3 minus ln of 8. Okay, but we're not done. So the first thing that I'm going to do is I'm going to simplify 10 to the power of 3. Well, 10 to the power of 3 is just 1,000. So this is ln of 1,000 minus ln of 8. Now here, I'm going to use another one of my my log properties. This log property says that if you have two logs with the same base being subtracted, you can rewrite it as a division problem. So that's exactly what I'm going to do. I'm going to rewrite this as ln of 1,000 divided by 8. Well, if I simplify that, 1,000 divided by 8 is equal to 125. Now, I could leave this here, but that's a really large number, and it can be simplified. So if you think about your exponents, like different powers, 5 to the power of 2, 5 to the power of 3, 125 is the same as 5 to the power of 3. So I'm going to rewrite it as ln of 5 cubed. And then I can use that same property that we undid up here to write this as 3 times ln of 5. Now we have a nice simple answer that does not have big numbers, so we are done. Nothing else can be done. Okay. For example B, we are again going to use those same properties, but this time we have addition. So like before, the first thing that I'm going to do is I'm going to move this number out front to my exponent. So that's going to give me ln of 40 plus ln of 1/2 to the power of 2 plus ln of x. Now I'm going to simplify that exponent real quick. So I have ln of 40 plus 1/2 squared is 1/4. So plus ln of 1/4 plus ln of x. And now that I've done that, I can use my other property that says when you have logs being added together with the same base, you can rewrite it as multiplication. So this gives me ln of 40 times 1/4 times x. And then I just simplify that. 40 times 1/4 times x, that's just going to give me ln of 10x. Not a big number, nothing can be simplified, so that is your answer. Okay, so all we did was we used those properties of logs that we've already learned to simplify both of these expressions. On the next slide or two, we have a couple more examples that I've already filled out for you. So go ahead when we get to them, pause your video, copy them down, and go on to the next one.
Sorry, I couldn't hear what you said.
Sorry, my watch wanted to help. Okay, so here's the first example. It's already filled out for you. Go ahead and pause your video now, copy it down. And then here's that next one. Again, pause your video now, copy it down, and when you're done, go on to the next slide. All right, now that we've simplified using our log properties, the next thing that we're going to do is solve base E equations. Okay, now to do this, we have a couple rules up here in the right-hand corner. Okay, it states that e to the power of ln of x, the e and ln cancel, and you're just left with x. In contrast to that, if you have ln of e to the power of x, the ln and e again cancel, and you're just left with x. So we can use this rule, this property, to help us solve these base e equations. Okay, but before we can do that, the first thing we need to do is we need to get that e by itself. So I'm going to start by adding 5 to both sides. Okay, so that gives me 4 times e to the power of negative 2x is equal to 8. Next, I'm going to divide by 4. That way, I can get that e by itself. So that gives me e to the power of negative 2x is equal to 2. Perfect. Now, what I'm going to do next is I'm going to use this rule that we just talked about. Okay, so to get rid of this e, all I need to do is take the natural log of it, or take the ln of e to the power of negative 2x. But if I take the natural log of this side, I need to take the natural log of this side as well. Okay, so I have ln of e to the power of negative 2x is equal to ln of 2. Well, like I said before, the ln and the e cancel, and all I'm left with is that exponent, that negative 2x. So this says negative 2x is equal to ln of 2. Now I'm just going to bring this up over here so I don't run out of room. Negative 2x is equal to ln of 2. And now I'm just going to solve for x. So to get that x by itself, I'm going to divide by negative 2, and x is equal to ln of 2 over negative 2, which is approximately negative 0.3466. There should be a natural log button in most calculators. I will double check tomorrow and let you know if the dollar store calculators have them, but I'm pretty sure that they do. Okay. So on the next slide, we just have 2 more examples exactly like that worked out. So again, go ahead and pause your video now, copy down both of these examples so you have lots of examples that you can look back on when y'all go through your notes, because I know y'all do that all the time. Okay, so go ahead and copy these 2 examples down now. When you're done, just go ahead and go to the next slide. Now, what we're going to do here is we are going to solve base E or natural log equations and inequalities. Now, the way that we do equations and inequalities is exactly the same, but I will show you an example of each just so you're sure. Okay, so example D here, we have 3 times ln of 4x is equal to 24. So just like when we were dealing with the natural base exponentials, when we're dealing with natural logs, we need to get that ln by itself. So to start, I'm going to divide both sides by 3. That's going to give me ln of 4x is equal to 8. Now, here's where we use this rule again. Last time, to get rid of the exponents, we took the natural log. This time, we already have the natural log. So to get rid of that natural log, we're going to take e to the power of it. So I'm going to say e to the power of ln of 4x. And if I do it to the left side, I also have to do it to the right. So this becomes e to the power of 8. Okay, now like we said, the e and the ln cancel, so I'm just left with 4x is equal to e to the power of 8. Now we're going to solve for x like normal, so I'm going to divide by 4 on both sides, and that leaves me with x is equal to e to the power of 8 over 4, which if you put into your calculator, because there is an e button on normal calculators, is approximately 745.2395. Excuse my ugly box. Okay. Now, for the next one, we have an inequality. But like I said a second ago, the way that we do it is going to be exactly the same. So first thing that we need to do is get the natural log by itself. If you notice, it's already by itself. We have ln of x minus 8 to the 4th power is less than 4. So now I can use this property up here. So just like the last problem, I'm going to take e to the power of all of this, ln of x minus 8 to the 4th, and then I'm going to take e to the 4th power over here as well. Just like before, the e and the ln cancel, so I'm left with x minus 8 to the 4th power is less than e to the power of 4. Okay, well, to get rid of a fourth power, I just take the fourth root. So I'm going to take the fourth root of both sides. The fourth root of x minus 8 to the fourth just leaves me with x minus 8, and the fourth root of e to the fourth is just e. Now, my last step is to get x by itself, so I'm going to add 8 to both sides. So I get x is less than e plus 8, or x is less than 10.7183. Okay, and that is it. No number lines, nothing. We just solve it like an equation, except we have an inequality symbol there. Now, just like the last few we did, there is going to be another 2 examples on the next slide. Just go ahead and pause your video, copy those down, and when you're done copying them down, move on to the last slide. So the last slide here is just giving you the equation for continuously compounded interest. So previously, way back at the beginning of this unit, we talked about compound interest. It was A equals P times 1 over R to the power of R times T, I believe, off the top of my head. When we looked at that, it was compounded in some time frame. It was compounded monthly or compounded daily, yearly, weekly, some amount of time. This formula happens when your interest is compounded continuously. So it's always being compounded. It's always being added up. So for the formula for continuously compounded interest, we have A equals P times E to the power of RT. We aren't going to do anything with it right now, but make sure you have that equation written down. P still stands for your principal, R still your rate, and T is your time. Make sure you write down all of your notes and have them ready to check for me tomorrow so you can get that free 100. Y'all have a great day, and I'll see you soon.